So there we go. So refrigerants that possess glide have become much more common over the last 20 years. And we're going to find out what refrigerant glide is. Why do we have refrigerant glide? And what are some of the effects of refrigerant glide that we need to be aware of? And how we can find these things out via the log pH diagram. Paul Singh has done a masterclass on pH diagrams already, and it's well worth a rewatch if you haven't. If you have, and if you haven't, it's very worth a watch. So let's get on to the what. So the what of refrigerant glide is quite simple. A refrigerant is deemed to possess temperature glide when, for a given pressure, there is a difference between the saturated liquid temperature and the saturated vapor temperature, and such refrigerants are called zeotropes. So here is a temperature enthalpy graph showing, and I'll just get my pointer up, which shows how sensible and latent heat changes during a change of state in single components like water. And these are called azeotropes. So if we take the example of a kettle, we put cold water in, we heat it up, and we get a sensible increase in heat. That is sensible. And then when we start to boil, we get no change in temperature, and we'd get a change in enthalpy until we fully evaporate our liquid, and it becomes, in this case, steam, and we heat the steam further, and that increases temperature normally. And that is pretty much what we're all taught in our refrigeration courses. Now, here's another graph showing how a zeotrope reacts. As we evaporate, our average temperature increases, and as we condense, the reverse occurs. The bubble point is on the line of saturated liquid, and that's defined as the first bubble to appear when we start to boil. And the dew point is on the saturated vapor curve, and this is the first dew to appear when we condense. And here is a pressure temperature graph showing the different pressure temperature relationship that liquid refrigerant of R448A has compared to when it's a vapor. And this area here is glide.